Good afternoon, Mark Sudduth, HurricaneTrack.com, here with your Hurricane and Hurricane HD video blog for Friday, July 13th, 2012. Hope you're having a good end of the week. The tropics not a concern, and I'm going to show you why. It's really interesting what's going on out there. You see in the tropical Atlantic this very stable and dry air mass, and you say, well, how can you tell that it is stable and dry? Just by looking at a satellite picture. A lot of these clouds here give us a clue to that. These are very low clouds, and they indicate, and I say low, they're very low in the atmosphere. They are just above the surface, only a few thousand feet above the ocean, sort of a low stratocumulus deck of clouds, if you will, meaning that they're kind of layered and they're cumulus clouds. So if you were out here in a boat and you looked up, it would have that beautiful mackerel sky look to it, like the side of a fish. That's why they call it a mackerel sky. And you can just tell that the air here is kind of dusty. I know it's hard to transmit over the video here, but the air here has got this milky, sort of dusty look to it. And this is a visible satellite picture, so you get to see some of the finer details of what goes on in the atmosphere, but all in all, a very dry, stable environment out here. And then this little wisp of clouds coming across like that, that is strong upper-level winds cutting across the region, so the tropical Atlantic is closed for business. One of the other tools that we can look at, and I wanted to show you this and compare it to the Eastern Pacific, why things are not cranking in the Atlantic right now. The tropical Atlantic vertical wind shear, the difference in the wind speed with height. Remember that tropical cyclones do not like a lot of wind cutting across them. They have to have the wind fanning out way up at the top of the outflow level, around 200 millibars in the atmosphere, real high up, where the wind goes out clockwise in all directions, fanning away, what we call a divergent flow aloft. The wind cutting across a tropical cyclone literally blows it apart or shears it, just like if you blow out a candle with a breath. Alright, a little puff, poof, it's gone. So the vertical wind shear can be measured, and the black line is your climatological average of where it should be. And throughout the hurricane season, it should continue to diminish, so that by the time we get to the peak of the season, it's low enough overall that we would expect an increase in tropical cyclone activity. Well, today, it's up here, meaning that vertical wind shear is above the climatological average, and that's one of the reasons why we don't have anything developing. The other reason is the vertical instability, the ability of the air to rise and lift and become unstable. The air is just too dry in the mid-levels and the low levels, and you can see that the vertical instability has been on the low side of the climatological average for most of the hurricane season here, and even since spring. And what we would be looking for on this particular graph is to see if it bounced up here on the top of the line, if it went above the climatological mean, but it hasn't been. It's always been running parallel, but certainly below the normal, the average. So vertical instability right now running quite a bit below where it should be, and a big reason behind that is the Saharan air layer, that dry air. This is a different satellite product from the University of Wisconsin that detects that dry air, and you can see it really curled up here, a tropical wave coming off, but it's so dry. This big cyclonic gyre of very, very dry air blasts off the African continent through an easterly jet stream, and with it comes dry air. An unbelievable, hostile environment for tropical cyclones to form. Conversely, in the Eastern Pacific, the vertical wind shear, as you can see right now, is just a little bit below the climatological average, and it has been for the last little while here, actually fairly well below, when we have seen this big burst of the D, E, and F storms in the Eastern Pacific. There you go. The wind shear has been below average. Interestingly enough, the vertical instability has also been running below normal in the Eastern Pacific, yet we have still seen this development. You can imagine what it would have been like had the vertical instability been on this side or running above normal. So interesting to compare the two, that the shear is below normal in the eastern Pacific. Water temperatures there, of course, are very warm, and you see on the water vapor imagery a similar type satellite picture where we can see moisture. All of this area is very rich moisture in the atmosphere, still running below normal in terms of the vertical instability. That is why, at least partly probably, that Fabio here, it's just funny saying that, Tropical Storm Fabio is not rapidly intensifying. So conditions are favorable to get strong storms, and Amelia became a Category 4 at one point. Daniel was a hurricane. This will become a hurricane, but it's not ideal out there. Conditions are not. Now look at Amelia here as we talk about what's going on for the forecast. Here's Hawaii. All of this sort of bronze color, copper to bronze color, whatever you call that, that is very stable, dry air as well. So Amelia is going to be leaving this environment that it has a little bit of moisture to work with. It'll leave that, move west into this very stable environment, and then die away. Fabio, on the other hand, is going to head up here. Yes, it will eventually reach a colder water temperature area where the atmosphere above that water is very stable. But all of this here is a result of colder Pacific water that is just not putting enough energy into the atmosphere, especially the lower and mid levels, to provide that lift, that vertical instability needed to power these tropical cyclones. So Amelia will move out here towards Hawaii, but it'll die off. Fabio will move back to the northwest. If we take a look at those tracks now, by the time Amelia reaches out here, it'll be gone. It'll be post-tropical in all likelihood, meaning basically it's at the end of its life as it runs into that dry, stable environment. There's the track for Fabio. Not a concern for Mexico at all. It'll remain well offshore, and things will hopefully quiet down after that. So I thought I'd give you a different perspective on why things are the way they are today, at least some of the reasons. Tropical cyclone genesis, or what we call tropical cyclogenesis, the fancy term for it, is complex. And it's not just based on warm sea surface temperatures and a pre-existing disturbance, i.e. an area of showers and thunderstorms. You have to have other ingredients in place. And these systems are so delicate, believe it or not, that even the slightest change in humidity in the atmosphere, the surface temperatures of the ocean, and especially the heat content of the ocean, how deep that warm water extends, all of those things can affect the birth of these tropical cyclones, and then once they get going, how they react through their lifetime. So that's what I wanted to take a look at today. Hopefully it made sense to you. Alright, well that's it for now. Again, I'm Mark Sudduth, HurricaneTrack.com, my website. Hope you learned something today. I'll be back with another video for Hurricane and Hurricane HD tomorrow.